Hi guys, welcome to lesson 10.4. Now we're going to look at some systems that don't have a unique solution. So this will be starting up on page 180 in your book. We want to be able to explain when a system of linear equations has no solution and explain when a system of linear equations has infinitely many solutions. So you've seen equations like this. Now you want to relate them to systems. So when does a system, when and why does it have no solution or infinitely many solutions? So the graph of a system of linear inequalities, and I think that's a typo. I think we're still talking about equations here, not inequalities, but it's true either way, but I think we're talking about linear equations still, does not always result in a unique intersection point. Parallel lines have graphs that do not intersect. We already know that. That's the definition of parallel. And coincident lines have graphs that intersect infinitely many times. So lines that are on top of each other are coincident lines. So objects that are coincident lie in the same place. Coincident lines occupy the same location and pass through the same location in the same plane and pass through the same set of ordered pairs. So a system of parallel lines that has no solution would look like these two. If I graphed them, the first one would intersect at y equals 2 with a slope of -2. Would look like that. And the other one intersects at the y-intercept of -2, going down 2 for a slope. And so that line would look like that, if they pretend they're straight. But this system has no solution. There's no place they intersect. And a system of coincident lines has infinitely many. So this would look like, if I graph the first one, that's that same line again. Looks familiar. So that's that line. And then this one, if I solved it for y, I'd get, let's see, if I minus 6 from both sides, I'd have -3y equals 6x minus 6, then divide by -3. So y equals -2x plus 2. So this one, if I graphed it, they didn't look the same to begin with, but now if I put this on the graph, there's my y-intercept, here's my slope, and I end up with the exact same line. So these are coincident lines and they have infinitely many solutions. All right, so on a particular trip, Roy leaves from Pecos driving 55 miles an hour. After 20 minutes, Travis realizes Roy forgot 2 cases of peaches. In 4 minutes, Travis loads the cases into his truck and heads out after Roy, traveling 55 miles an hour. This system of equations represents each brother's distance, d, from Dallas, h hours after Roy leaves Pecos. So Roy left, and so here's his equation, and we're going to graph the system. So let's see, it goes 55 miles an hour, so that's 110 every 2 hours. So 340, oh, this is only going to be a ballpark. I hate this scale. And then that would be 230, so maybe, let's see, this is going by 45s. And then 230, so 120. So roughly, your points might be slightly better than mine, but boy, that's not straight. And then if I solve Travis's equation, I have to distribute this, so I get d equals 450 minus 55h plus 22. So his is 472 minus 55h. So he's going to start up here, be about here. And I'm not going to try to find a bunch of points, but I do notice that it's the exact same slope, so these two lines are going to be parallel. I don't know how perfect I'm going to get here. Wow, I can't even draw. Oh boy. Okay, those are 2 straight lines. You're using your imagination here. So when we describe the graph, we get parallel lines. Oh, yes, I know you're using your imagination. You can hold this against me forever. What information about Travis and Roy does the graph provide? Well, it tells us that Travis will never catch up. He's not going fast enough, so he won't be able to he won't be able to give the peaches to Roy until he gets to Dallas. More than 8 hours later. How many solutions exist to the system? None. There are no points where they intersect. So these guys are never going to meet up on that trip, not until they get all the way to Dallas. All right, so the system below represents a return trip from Dallas to Pecos, where D represents the distance from Pecos 8 hours after Roy leaves, 8 hours after Roy leaves Dallas. So here's Travis's 450 minus 68. I'm just going to cut to the chase on this one and figure out when he's going to get to Pecos. So I'm going to do 450 divided by 60, and that means 7.5 hours it's going to take him. So I'm just going to make my line go that way rather than find a bunch of points. And it would be so great if it was a little bit straighter. And then let's see here. Roy's would be, if I distribute that, I get D equals negative 60H plus 450. And that is the exact same equation as this. Do you recognize it? It's positive 450 minus 68. So his is going to be the exact same line there on top of Travis's. What information about Travis and Roy does the graph provide? They are on the same trip to Pecos. They're exactly at the same time. How many solutions exist? There are infinitely many. At any point, their coordinates are the same. So whoever's line you pick a point on it, the other guy will be at that exact same point on his line because they are the same line. So hopefully that gives you an idea about the special cases when there are infinitely many or no solutions to a system. And if you have any questions, bring them on in and we'll pick it up in class.